Module 20.2 Day 2. Arc length and radian measure. Prove that all circles are similar. Language objective. Explain to a partner how to convert the measure of an arc from degree to radian. So let's review what we learned from yesterday. So yesterday we said that the formula for the arc length is S equal to the measurement of the arc degree divided by 360 degree times 2 times pi times the radius. Okay, so let's investigate. Right? Consider the set of concentric circles with center O and radius 1, 2, and 3, and so on. The central angle shown in the figure is a right angle, and its cutoff arc that measure 90 degrees. Right? So example 2a. For each value of the radius are listed in the table below, find the corresponding arc length, write the arc length in terms of pi, and round to the nearest hundredths. So for example 1, when the radius is 1, we have the arc length 90 degrees divided by 360 times 2 pi times 1 equal to 1/2 pi, and round up to 1.57. Well, when we look at this, when the radius is 1, we get this term, right? So this is our constant term, it will not change. So when the radius is 2, so we just times this by 2. So this gives us pi, and this is 3.14. Right? And when the radius is 3, we still use 1/2 pi times 3. So this will be 3 over 2 pi. And let's see, 3 over 2 pi. Okay, so this gives us 4.71. And 4, so it would be 1/2 pi times 4 reduced to 2 pi. So it will be 6.28. And this is 5 pi over 2. So 7.85. Right? Okay, and then so they want us to plot those points. So we have 1 and 1.57. So I'm just going to approximate here. And when the radius is 2, we get 3.14. So maybe there. And 3, oops, let me go back. 3, we get 4.71. So 3, maybe here. And for 3, 6.28. For 4, 6.28, so maybe here. And then for 5, 7.85. So maybe here, right? Okay, so is that what do you notice about the point? Well, the point as the right, so at the point they're going in the positive direction. What type of relationship is the relation between the arc and the radius? So well, we know that this 1/2 pi stay constant, and the radius is your variable change. And you say that what is the constant of proportionality in the relationship? The constant is it's always 1/2 pi. Right? Okay, so for number 4, what happened to the arc length when you double the radius? How it is connected to the idea that all circles are similar? Well, the constant term we have is 1/2 pi. Right, times the radius. So if the radius is 1, then this will be just 1/2 pi times 1. When the radius is 2, it's 1/2 pi times 2 or pi. Right? So then we see that this is in terms of our dilation. Okay. So, right. So then we can have pi over 1/2 pi, so they reduce to 2, so then the the scale factor k is 2. Right. So then, as you discover in example 2, when the central angle is fixed as m degree, the length of the arc cut off by the central angle is proportional to or vary directly with the radius. In fact, you can see that the formula of the arc length is proportional relationship where when m is fixed. So here, for example 3a, we want to convert 180 degree to a radian measure. Okay, so then we can have 180 over 360 times 2 pi, right? So then this is 1/2 times 2 times pi, which is reduced to just pi. Okay, so then we say that 180 degree is the same as pi, and this is in terms of radian. Okay, and this is in terms of degree. Right, now we want to convert 60 degree from degree to radian. Right, so this is degree. We want to change it to radian. So we can do 60 degree over 360 times 2 times pi. Right? So this is 160 times 2 would be 120 over 360 times pi. So this is 1/3 pi, or you can change it into a decimal. So it is 1.046, and this is in terms of radian. Right. So let's shorten this formula. Right. So let's look at this part. So we have m over 360 times 2 pi. Well, this can be reduced. It's the same as 2 over 360, so reduced to 180. Right? Okay, so then the formula we can convert from degree to radian is 1 over 180 times pi. So then we shorten the formula. Right. Okay, so then explain how to find the degree measure of an angle whose radian is pi over 4. Right. So we see that to go from degree to radian, we have times by. Right. So so then we know that we have something times 180 times pi equal to pi over 4. Okay, so then to solve for that means that x equal to pi over 4, do the reciprocal, so this is 180 over pi. So that they reduce. Then you do 180 divided by 4. So then this gives us 45 degrees. Right? Okay, so before we do all this, let me give you the formula for conversion. Right? So if you want to go from degree to radian, you times by 180 times pi. And if you want to go backward from radian back to degree, then you do pi over, oops, my mistake. And you do the reciprocal would be 180 over pi. Okay? Right, so let's start with number 7. So convert each angle measure to radian degree. So we have 90 degree times 1 over 180 times pi. So this reduced to 1/2 pi. Right? And then the same here for 45 degrees. We do 45 degree times 1 over 180 times pi. So this gives us 1/4 pi, or we can write it as pi over 4. Okay, so let's continue to try this. Change the given angle measure from degree to radian. Right? Remember, to go from degree to radian, you do pi over 180. So here we have 10 degree times pi over 180. Right, so it will be pi over 18. Right. Right, and then for each of these, if you want to, you can change it into a decimal by changing pi to 3.14. So this could be written as 1.74, right? And this is in terms of radian. So if you change it into a decimal, then you need to write RAD afterward to let your reader know that you have changed it into a radian, right? And if you leave it into a pi, then you do not need to write the word radian afterward. Okay, so that's the end of our 20.2 day 2. So you have your book set assignment, and you are to finish up your HRW and copy down 20.1 day 1 notes.